Hello students, welcome to online maths classroom. In this video, we'll learn about complex numbers and quadratic equations, basic concepts and solutions of exercise 5.1. So let us start with it. Now, what are imaginary and complex numbers? What happened that in early days of modern mathematics, people, when they were solving the equations of the kind x square plus 1 equal to 0, you know that you will get the roots as x square is equal to minus 1 and root of x square is equal to plus minus root of minus 1. Okay, now it is not possible. Why? That you cannot get a number which when multiplied by itself will give you a negative number. Okay, no such real number actually exists. And if we will plot the graph of this quadratic equation, you'll find that the parabola that you obtain, as you know that the graph of a quadratic equation is a parabola, the parabolic graph that you obtain is not touching x-axis. It is not touching x-axis. And you know, when it is not touching x-axis, in this case, the equation will have no real roots. Okay, no real roots. So for solving it, what happened that under root of minus 1 was taken as imaginary number and we call it as iota, denoted by small I. Okay, that means this I is equal to under root of minus 1 is called as iota. Now let us recapitulate the concept of discriminant and nature of root of quadratic equations. You know what is discriminant? That is b square minus 4ac. Now what were the conditions which we studied earlier? That if this discriminant is greater than 0, then the equation used to have two different real roots. Like if this discriminant is positive, two real roots will exist and either you can factorize the equation and get it, or you can use the quadratic formula like minus b plus minus. This root positive means the discriminant is positive, the value of b square minus 4ac upon 2a. And clearly the parabola, which is the graph of this type of quadratic equation, touches the x-axis at 2 points. That's why it has two real roots. Second condition was when discriminant is equal to 0. In that case, two equal roots were existing and it was touching x-axis just once. Okay, so discriminant equal to 0, one repeated root was there and you can get it as x is equal to minus b upon 2a, as plus minus this discriminant will be 0. And in this case the parabola is touching x-axis only at 1 point because only one repeated root is there. Third condition which we didn't use to solve in class 10th was when discriminant is less than 0, that is no real roots. And in that case your parabola was not touching x-axis. Okay, so for example, see this type of quadratic equation is there, 3x square plus 5x plus 9 equal to 0, in which discriminant is minus 83, which is less than 0. So no real roots used to exist. Now before starting complex numbers, let us understand the concept of real numbers. Okay, so real numbers were those numbers including rational and irrational numbers. And in rational number, what comes? Integers, whole numbers, natural numbers. Okay, why? Because whole numbers, they contain all natural numbers including 0. So this bigger shape or bigger parabolic shape is depicting that whole number is containing all natural numbers including your 0. Integers, they contain whole numbers and natural number also. That's why they are represented by this. And rational numbers, they include integers, whole numbers and natural numbers. So that's why they are expressed like this. Okay. Now, if some number system is there which is not included in these real numbers, okay, that system which is neither natural, whole, integer, rational, irrational or any kind of real number, then that belongs to the complex number category. Okay, now see what are complex numbers. So complex numbers will be the numbers expressible in the form of a plus b iota. Okay, a plus b iota, where a, b are both real numbers and this iota is under root of -1, that part that we discussed in the very first slide. Okay, so complex numbers are a plus b iota type of numbers. Now see, real number, any real number can be expressed as a plus b iota with the imaginary part b as 0, like -4, okay, like √3, like 0, 2 by 3, √7, 8. So I can write as -4 plus 0 iota, √3 plus 0 iota, 0 plus 0 iota, and like this. All rational numbers can also be included like this. Integers, see integers, out of these who are integers, -4, 0, 8, means integers can be also represented as complex numbers. Whole numbers like 0 and 8, and natural numbers like 8. Okay, so irrational numbers like √3, √7. Everyone, all these real numbers can be expressed as complex numbers with imaginary part b as 0. Okay, so let us see what kind of complex numbers are there. They will be the number of the form a plus b iota, means a, b are real numbers, like 3 plus 2 iota. Okay, 5 plus root -15, because this root of -1 will give me this iota. Inside the root, if some negative number is there, then it will give me iota. Okay, so the real numbers like pi, -2, √15, they are your real numbers. And purely imaginary means which will just be containing all the iota terms only, iota, -2 iota, okay, like this. And see the numbers like -pi, -iota. Now, no doubt, real numbers can also be expressed as complex numbers like -2 plus 0 iota, √15 plus 0 iota, and like this. So let us come to the formal definition of complex numbers. A number that can be written in the form of a plus b iota, where a, b are real numbers, is a complex number. A is the real part and b, I is the imaginary part. Okay, like 6 plus 2 iota, -5, -7 iota, 4 iota. Okay, all these are complex numbers, right? Because 4 iota can also be written as 0 plus 4 iota, as real part is 0. So this type of complex number is called purely imaginary complex number. Okay, so a complex number consists of real and imaginary part. A is real part, B is imaginary part, and this iota is your under root of -1, squaring which we will get iota square is equal to -1. Now let us understand how to solve iota. Iota is equal to under root of -1. Iota square is -1, squaring this. Iota cube will be iota square into iota, that is minus iota, because iota square is -1 and -1 into iota is minus iota. Iota raised to power 4 can be iota square whole square, that is -1 whole square 1, or it can also be written as iota cube into iota, that is minus iota into iota, that is minus iota square, and minus iota square will be minus of -1, that is +1. Okay, so that means if iota is raised to power a multiple of 4, then it will be having value as 1. Okay, and if iota is raised to power like 4n plus 1, it will be iota 4n plus 2 -1, and iota raised to power 4n plus 3 will be minus iota. Now how to add the complex numbers like a plus b iota plus c plus d iota? It will be, you have to add the corresponding real part and corresponding imaginary part, like b plus d iota, a plus c. Okay, for subtraction, again real parts will be subtracted like a minus c plus iota times b minus d. The multiplication can be done as, like it is a plus b into a minus b, so it is a square minus iota b whole square. So iota square will give me -1, so it will be a square plus b square. Okay, and also a plus b iota into c plus d iota is, your multiplication will be like ac plus ad iota plus bc iota plus bd iota square. And after solving, we can write it as ac, separating real and imaginary part, we can write ac minus bd plus ad plus bc iota. And while dividing two complex numbers, for expressing it in a plus iota b form, I need to rationalize it, and I will rationalize it using c minus d iota, multiplying and divide by c minus d iota. So after solving, we will get this expression after the separation of real and imaginary part. So we will work out in various questions. Like, let us take an example for division of complex numbers like 2 plus 3 iota upon 1 plus 2 iota. So to solve it and to bring it in standard form, I need to rationalize it. I'll multiply and divide by 1 minus 2 iota, and then here I'll multiply both the complex numbers 2 plus 3 iota into 1 minus 2 iota, as we have done, like 2 minus 4 iota plus 3 iota minus 6 iota square, and denominator as a plus b into a minus b, that is a square minus b square. So I'll get it as c. After solving and separating real and imaginary part, as iota square becomes minus 1, so it will be 8 minus iota by 5. And in standard form, it can be written as 8 by 5 minus 1 by 5 iota. Now we will solve exercise 5.1 on the basis of concept learned. From question number 1 to 10, you need to express all the complex numbers in the form of a plus iota b. So let us start solving how to express from 1 to 10 in the form of a plus iota b. And from question number 11 to 13, we need to find the multiplicative inverse of complex numbers. And in number 14 also, I have to express this complex number as a plus b iota. Let us start solving exercise 5.1. The question number 1 of exercise 5.1 says, express each of the complex numbers given in these exercises in the form of a plus iota b. A plus iota b, that is the standard form of complex number. So the first question of exercise 5.1 says that you have to solve 5 iota and minus 3 by 5 times iota. Now you know that it will be opened as 5 into minus 3 by 5, and iota into iota is iota square. Now we know what is iota square. Iota square is equal to minus 1. So I get the value as minus 3 into minus 1, that is equal to 3. So this is how question number 1 will be solved. Let us take question number 2. Question number 2 is, you have to express iota raised to power 9 plus iota raised to power 19 in a plus iota b form. So again, it can be expressed as iota square raised to power 4. That will give me iota 8 into iota. Okay. So bases are same, powers will be added. So 2 4s are 8 plus 1. It will make your iota raised to power 9 plus iota square 9 2s are 18 into 1 iota. Now again, using iota square is minus 1. So I'll take it as minus 1 raised to power 4 into iota plus minus 1 raised to power 9 into iota. So this even power will give me plus 1, and it will give you iota, and this odd one will give me minus 1, and it is minus iota. And this both can be cancelled, and I get the answer as 0. Now question number 3. Question number 3 says, you have to solve iota raised to power minus 39. Express it in the form of a plus iota b. Now you know, for a negative power, you need to express it as 1 upon iota raised to power 39. Now whatever we were doing in the numerator, like the same thing we want to express as iota square 19 2s are 38 into 1 iota. It makes iota raised to power 39. Then again, iota square is minus 1, so it is minus 1 raised to power 19 into iota, which is your minus 1 upon iota. Now, it is not the standard form of the complex number. Okay. For standard form, I should express it in the form of a plus iota b. So, what I need to do is, I will rationalize it. So, it becomes minus iota upon iota square, which is your minus iota, and it is minus 1. So, it gets cancelled and I get the answer as iota. And in standard form, it can be written as, if I need to express it in standard form, it can be written as 0 plus iota. If it is to be expressed in the form of a plus iota b. Okay. And similarly, in very first question, your 3 can be expressed as 3 plus 0 iota. If we need to express it as a plus iota b. 3 times 7 plus iota 7 plus iota 7 plus iota 7, and you have to express it in the form of a plus iota b. So again, I will just open it. I'll multiply. It is 3 sevens are 21 plus 3 sevens are 21 iota plus 7 iota plus 7 iota square. Now the term which is having iota square will be changed as minus 1. So this term will become real part. Okay. So it is like 21, and from here I will get minus 7. So I'll associate the real part together and the imaginary ones together. So it is 21 plus 7, that is 28 iota, which is your 14 plus 28 iota. So this is how it can be expressed as a plus iota b. Question number 5 is, question number 5 says that you have to express 1 minus iota minus minus 1 plus iota 6. So it is again very simple. Just open the power. Be careful about the signs. Plus 1 minus 6 iota or iota 6. It means the same thing. So it is your 2 and it is minus 7 iota. So this is simple thing. Number 6. Number 6 is 1 upon 5 plus iota 2 by 5 minus 4 plus iota 5 by 2. So again, just bring together the real parts and imaginary ones are also. So it is 1 by 5 minus 4 plus iota times 2 by 5 minus 5 by 2. So it becomes 5 4s are 20, minus 20 plus 1 is minus 19 by 5 plus iota. The LCM will be your 10 and it will be like 4 minus 25. So it is minus 19 by 5 plus, but I'll get the minus sign here as it is your minus 21. So it is minus 21 by 10 iota. So this is how question number 6 will be solved. 7 is 1 by 3 plus iota 7 by 3 plus 4 plus iota 1 by 3, and this bracket is altogether minus 4 by 3 plus iota. And again, you have to express it in standard form. So what I am going to do is, again, firstly I'll solve everything inside this bracket. Again, bring together the real parts. Okay, and plus iota times 7 by 3 plus 1 by 3. And iota is outside, 7 by 3 plus 1 by 3. Okay, minus, let's not open it, because when we will just fix these two together, then at that time we will work it out. So it is your, after taking LCM, it becomes 3 4s are 12 plus 1, 13 by 3 plus this is 8 by 3 iota, and minus 4 by 3 plus iota. Now I need to bring them together. So again, this is real part and this is its real part. So it is 13 by 3 and minus, that is plus 4 by 3. Okay. Plus iota, this is 8 by 3 and it is C, minus minus. So it is minus 1. Okay. So it becomes your 17 by 3 plus iota and it is 8 minus 3 is 5. 5 by 3. So I can write it as 17 plus 5 iota by 3, which is my required form as A plus iota B. So next question is question number 8. Question number 8 says how to express 1 minus iota raised to power 4 as A plus iota B. So what can I do is I can use the formula of A plus B raised to power 4. Dear students, when you will have the knowledge of this binomial theorem, you will be easily able to expand the higher powers also. So it starts like A4 plus A cube B. The power of A starts decreasing by 1 and the second binomial element starts getting added up. So it becomes A cube B, okay, plus it is, I am not writing the coefficients right now, then it becomes A square B square, okay, then it comes A B cube and it ends at B raised to power 4, okay, and here comes 4, here comes 6 and here also 4 is there. And this A4 and B4 are same. Okay, so let us apply it by taking A as 1 and B as minus iota. So it will be 1 raised to power 4 plus 4 A cube B. Okay, take B as, because I am using the formula for A plus B raised to power 4. So take B as minus iota. Okay, plus 6 A square B square plus 4 A B cube, okay, B cube and plus your B raised to power 4, okay. So it is your, this is 1, okay, and it is your minus 4 iota. This is your iota square is minus 1 and see, be carefully, it is as minus iota whole square. So it will just be iota square, not minus iota square, because minus sign will also get plus sign as we are multiplying. It is like minus iota into minus iota. So it will be iota square, which will be minus 1. So it is minus 6. From here, you will get minus iota cube. Okay. So let me write it as minus 4 iota cube can be written as iota square into iota. And this is your iota raised to power 4 and the sign will be of plus. So plus iota raised to power 4 can be written as square square. Or you know the value of iota 4 also, that is plus 1. Okay. So directly we can also go for it. So it is 1 minus 4 iota minus 6. This is iota square is minus 1. So it is plus 4 iota and it is your plus 1. Okay. So 2 minus 6 is minus 4 and this becomes 0 as this gets cancelled and can be written as minus 4 plus 0 iota. So this is how we expand A plus B raised to power 4. Now question number 9. Question number 9 is 1 by 3 plus 3 iota whole cube. Now you know how to solve it. We will apply the formula for A plus B whole cube, which is your A cube plus B cube plus 3A square B plus 3AB square. So it will be like A is 1 by 3 whole cube plus 3 iota whole cube plus 3 1 by 3 square, B is 3 iota plus 3 A and B square. Okay, so it is 1 by 27. It becomes your 3 iota cube is 27 and iota cube can be written as iota square into iota. Plus it is 3 into 1 by 9 into 3 iota plus 3 into 1 by 3 into 9 iota square. So it is 1 by 27. Okay, iota square is minus 1. So it is minus 27 iota. And this gets cancelled here. Plus it is iota. Okay. And then 3 gets cancelled and 9 iota square is your minus 9. Okay. Now next is that what I can do is I will just change it as 1 by 27. I'll bring the real parts together, imaginary parts together, and is equal to it is minus 26 iota. So now let us take the LCM here. So it is 1 by 1 minus 9 into 27 divided by 27 minus 26 iota. So it is 1 minus 243. Okay, minus 243 by 27 minus 26 iota. So it will become, it is minus 242 divided by 27 minus 26 iota. Okay, so this is your required answer of this question. Minus 242 minus 26 iota. Minus 2 minus 1 by 3 iota whole cube. Now again I'll apply the formula of a plus b whole cube, which is your a cube plus b cube plus 3a square b plus 3ab square. I always suggest to use the formula of a plus b instead of a minus b, because what's the mistake is committed by student is that they apply the formula for a minus b and taking also the b as minus 1 by 3 iota, and that will be the wrong solution. So always start with your positive formula. Take a as minus 2, b as minus 1 by 3 iota, and that way the correct formula will be applied. So it becomes a cube plus b cube plus 3 a square b plus 3 a b square. Okay, it is 3ab square. Okay, so it becomes minus 8 minus 1 by 27. Okay, it is iota cube, iota square into iota, and it is plus 3 into 4. Okay, into minus 1 by 3 iota plus 3 into minus 2 into minus 1 by 3 into 3, 1 by 9. Okay, iota square. Okay, and this as is minus square, so from outside the term will be coming as the plus term. So it is minus 8 minus 1 by 27, iota square is minus 1, so into minus iota plus, okay, so as see it is minus 4 iota, so I'll just take as minus 4 iota, and it is your 313 gets cancelled with this, and it is your minus 2 by 3 iota square will give me minus 1. As you know, iota square is minus 1. Okay, so this way you will get the real terms as minus 8 by 3, and this is plus 2 by 3, and this is plus 1 by 27 and minus 4 iota. Okay, I have arranged the terms. So here, after taking LCM, 24 plus 2 by 3 plus 1 minus 4 into 27 divided by 27. This iota. Okay, now it is your minus 22 by 3, and it is plus. Okay, so check what is 27 into 4 is minus 108. So it is 1 minus 108 upon 27 iota. So it will give me minus 22 by 3 minus 107 upon 27 iota, which is the required expression of this cube in the form of a plus iota b. Question number 11 is find the multiplicative inverse of a complex number 4 minus 3 iota, and we call this complex number as z. Now you know the multiplicative inverse means the multiplicative inverse of z is 1 upon z or z raised to power minus 1. So the multiplicative inverse of z will be your 1 upon z, that is 1 upon 4 minus 3 iota. Now you know it is not the standard form of complex number. So I need to rationalize it to bring it to the standard form. So it is 4 plus 3 iota upon 4 square minus 3 iota whole square. So it is 4 plus 3 iota upon 16, okay, and it is your minus 9 iota square. Iota square is minus 1, so it is 4 plus 3 iota divided by 16 plus 9, which is your 25. So it is 4 plus 3 iota and denominator is 25. So I can write it as upon 25 plus by 25. So this is the multiplicative inverse of our 4 minus 3 iota. Similarly, the next question is find the multiplicative inverse of complex number root 5 plus 3 iota. So again the multiplicative inverse is 1 by z root 5 plus 3 iota. To solve it, I need to rationalize it. So it is your root 5 minus 3 iota upon root 5 whole square minus 3 iota whole square. So this is root 5 minus 3 iota and this is 5 and this is your minus 9 iota square. So it will be root 5 minus 3 iota upon 5 plus 9, that is 14. So it will be root 5 minus 3 and upon 14 if I separate the real and imaginary parts. So this is how we find the multiplicative inverse of this complex number. Now to find the multiplicative inverse of complex number, question number 13 says z is equal to minus iota. Now the multiplicative inverse is 1 by z, which will be minus 1 upon iota, and just rationalize it, minus iota upon iota square minus iota upon minus 1, and which is your just iota, which is in standard form expressed as 0 plus iota. Question number 14. Question number 14 is you have to express this complete term in the form of a plus iota b. Now see, the numerator can be solved by using a plus b into a minus b, that is a square minus b square, and denominator can be opened. So it becomes a square minus root 5 iota whole square upon root 3 plus root 2 iota minus root 3 plus iota root 2. Now this is your 9 minus root 5 whole square is 5 into iota square, and this gets cancelled with this and it is 2 root 2 iota. Okay, 1 root 2, second root 2, so that means 2 times root 2 iota. Okay, which is your 9 plus 5 upon 2 root 2 iota, that is 14 by 2 root 2 iota, which on cancellation can be written as 7 by root 2 iota. Now it is not in standard form as iota is in the denominator, so I need to rationalize it. So it becomes 7 root 2 iota upon 2 iota square, which is 7 root 2 iota upon minus 2. Okay, so that means I just get this as 7 root 2 upon minus 2. So how will I write in the standard form? It will be, as real part is 0, so it is 0 minus 7 root 2 iota
upon 2. So this is the required answer of this question.
I hope the concept of complex numbers and quadratic equations topic is clear to you. We will take rest of the problems in next part. Thank you so much.